Hey everyone, today we are going to solve LeetCode problem number 200, number of island. It's a pretty standard graph problem and has been asked in a load of tier 1 companies within the last 6 months. It's a pretty standard DFS question and asked quite frequently in the interviews. Let's have a look on the problem statement. In this problem, we are given a grid which is having values 0 or 1. Let's say it is something like this. We have one character 1 and character 0 in this grid, and this grid will represent the map, the land map, and in this map the one value is going to represent the land portion and the 0 is going to represent the water. What we have to return is we have to return the number of island in this map. And how we are deciding an island? The islands are the ones which are connected land nodes horizontally or vertically. Let's say if there are 5 land nodes, these land nodes are connected horizontally or vertically. These will be the part of one island. So here in this case, this is one island and there is no other island, so we are going to return 1, that our map is going to have one island. Let's say it was something like this: 1 1 0 0 0 1 0 1. In this case, this land node, land node, these are connected horizontally or vertically. This will form one island, and this is not connected. Now we'll start from here. This is only one node, only one land node will make one island. So this is island 1, island 2. In total we are having 2 islands. So this is we have to return as a input. We are going to have this grid having 1 and 0 only. We are going to get input something like this. So in this question, let's try to see how many islands we have. This is the land node, so our island, it will be part of any island. So this is connected to this horizontally, so these will be the part of one island, these will be part of one island, these and these. So all of these one will be the part of a single island. So island 1. Apart from that, I don't see any land node in this. No other land is remaining. It means I'm going to return 1 as an answer. If I have a look on this example, how many land nodes we are having. So currently we are going to start from any land node. This is the land, this is land, and this is connected horizontally, sorry, vertically. This is vertically. I think this is one island. This is island 1, because no other nodes are connected horizontally or vertically. It is surrounded with water. Now we'll keep on searching for another island. This is another island, and this is not connected to any other land horizontally or vertically. Okay, so this will be the island 2. Now we'll keep on searching for another island. We got this land. This land piece is connected to this land horizontally, so these two will be the part of another island. So island 3, this is one island, this is one island, and this is one island. So in this question, in this grid, we are having 3 islands. So what we are doing here is we are getting a grid of m cross n. So at any index I comma j, I will see whether that node is a land node or water node. If it is a land, I will keep searching for the horizontally or vertically in the all 4 direction. If we keep on encountering that land, it means all of those connected nodes are a part of one island. In this way, we will just get one island. So DFS call get started at ij, where ij is having a value 1. So here, let's say I started with this. I'm going to move in the 4 directions: right, bottom, left, and up. Left and up are discarded because we are going out of boundary, and also we can consider that it is a water. And the right and bottom is also 1. It means these are also part of this node. So I made a right call. Right call will also go to left, bottom, up and left. But here we cannot go left. It means we have to take care of the visited nodes as well. So how we are going to take care of the visited nodes? You can take a boolean 2D array, or as here in the question, in the problem statement, we just have to return the number of islands. So if we encounter one island, I'm going to mark that island visited, or maybe I'm just going to manipulate the value. Maybe from 1 I'm marking it to back to 0. I will be marking it to 0 so that it will not come to it this again. And once the DFS call is completed, these 4 are marked. It means these 4 will be like this after this one DFS call. So one DFS call is made. So one DFS call will contribute to one island. After that, we will be at this position, the center one. So from this center one, we will make another DFS call. So that DFS call will mark this center one visited. These 4 are visited, this will be visited. So this will again be 0. And this to second DFS call will contribute to the second island. And this will contribute to the third island. It means the number of DFS call will be equal to the number of island we are having. So for I equal to 0 to m and j equal to 0 to n, if grid I j equal to 1. If it is a land, we are going to make a DFS call. If this DFS call is made, it means we are marking one island visited, and we can increment our answer by 1 because corresponding to that island which is just marked visited. So this is going to be our main call, and in this main function we are making a DFS call whenever we are encountering 1. Next time we will not encounter 1 because we will be marking it to 0. So in our DFS call, I'm going to have ij index. If it is going out of bound or water, if it is going out of bound or a water case, we are going to just return from this call. Otherwise, grid ij is equal to 0. It means marking it visited. After that, what we have to do is DFS I plus direction 0, j plus direction 1. I wrote this for loop to move call to these 4 directions. So all of these 4 directions I will go and mark each land node connected to this island visited. So this is only our DFS call. Let's have a look on the code as well as the time and space complexity. To have a look on the time and space complexity, what I can do is I'm going to visit each node. Let's say I am at the first node. I'm marking it marking it visited or making it 0, and then moving to the other nodes making those visited. So in the worst case, I will be moving to each node at least once. So the time complexity is going to be m cross n. And what is the space complexity? Space complexity is something like it depends on you. Like let's say if we have taken a boolean array for the visited section, it's going to be order of m cross n. Let's start writing code for this problem. First of all, I have taken some global variables m cross n dimension of the grid so that I don't have to pass it with the DFS function. I'm taking a grid global as well. This answer is going to store the number of island our map is having, and these are the direction, the x and the y coordinates. That is, in these direction I will be moving from ij index. So first of all, I'm initializing my answer to 0, and this dot grid will be equal to the local grid, and m is equal to grid dot length, and n is equal to grid 0 dot length, number of columns. So I will I will try to visit each node and I will see whether it is a part of an island or a voter. So if I equal to 0, I less than m, I plus plus. For I j equal to 0, j less than n, j plus plus. If grid I and j equal to 1. If it is a character 1, it means it's part of an island. I can start my DFS call from here, and after DFS call my answer will be incremented. It means I have marked one island as visited. So in the end I'm going to return my answer, and in the DFS call I have to make a condition. I When will I stop my DFS call? When I'm going out of the bound, that is I less than 0 or j less than 0, or I equal to m or j equal to n. And there can be case when I'm going to the voter within my map. Grid of I and j equal to 0. In this case I'm going to return from the DFS call, otherwise I have to mark this call, this node as visited. To make this call as visited, I'm like using 0, so that next time it will be considered as voter and it will just drop the call. Otherwise I have to move to the 4 direction. Instead of 0 you can take another value as well, but you have to mark that inside the condition. Otherwise if you do not want to modify the input grid, you can just take another boolean 2D matrix to store whether any node is visited or not. So for each direction int d direction, I'm expanding my DFS call. So DFS I plus D0 J plus D1. Try to test over sample test cases. The output is coming as 1. Okay, what's the mistake here? This is a character grid. So instead of 0 as a integer value, I have to take 0 as a character. Now let's try to test again. Okay, here as well we have to mark it as 0 character, not the 0 integer. Sample taxes are passed. Submitting the problem. Submitted successfully. Hope you understood the problem. We follow the DFS approach here. You can just have a try on the BFS approach by your own. Okay guys, bye bye. Thank you.